So continuing upon how we just try to see the notions of space and time as seen in the 20th century physics, and how reformulated in the way the space, the Einsteinian space-time, the Newtonian space-time, and the way people like Whitehead and how Iqbal also tries to see forward a certain point of view of space-time. So in that context, you can say, for example, if we'll continue with that, so for example, what Iqbal says, that criticism of the foundations of mathematical science has fully disclosed that the hypothesis of pure materiality and enduring stuff situated in absolute space is unworkable. So is space an independent void in which things are situated, which would remain intact if all these were withdrawn? The ancient Greek philosopher Zeno approached the problem of space through the question of movement in space. Now, it's a very interesting debate which Iqbal is alluding to. The philosopher Zeno, maybe historically known, it's maybe in the Greek era, the times of Socrates, the times of maybe the peripetics, the schools, Plato, Aristotle, and maybe Socrates. He was in the same era, and he tremendously influenced. It's said that Aristotleian school, how was influenced by the volley of questions. And the responses which Aristotle gave to those questions. So those questions, even if modern day mathematicians or modern day philosophers, for a good number of them, or they seem to be resolved, but still they have a sort of intellectual value to them. Because even now the sort of questions or the sort of puzzles or sort of debate which Zeno just introduced by his how he tried to just those puzzles or these things, those questions can still be reformulated in 20th century, 21st century, the way they have been in back BC in that sense. So since Zeno, a lot of things, a lot of water has gone down the what I should say stream, and things have been there, but some of the contentions or some of the questions or some of the doubts which Zeno has expressed in his times, they can still be reformulated or reworded at different debates in modern day mathematics. But the sophistication of modern day mathematics, whether it's Cantor's theory, whether it's Zermelo's set theory, whether it's continuum hypothesis, the way we address, or whether they are paradoxes in logic, or whether it's Russell hypothesis. So whatever the vocabulary with which we have tried to permanently resolve those very questions, as if those questions can be sidelined, or they can be circumvented, or they can be not done away with, but they can be properly bypassed. The way how we study modern real analysis, but it doesn't somehow discount the arguments which are there in that sense. So what we are going to do, we are going to see the way historicity of the Zeno's argument within the background of Aristotelian sciences, and connect it the way people like Russell, people like Cantor have tried to address the issues, and how Iqbal has maybe given there are some good insights maybe towards the end of it, where he has not given solution to the Zeno's paradoxes, but he has given some interesting insights which can be read within the history of entire the history of Zeno's paradox since BC to up to this time. So what I'm going to say is, what we are going to do is, first we are going to read these things. So I'll go to see maybe. So maybe that Zeno's thing is that that actually thing. If you have, if there is a, and there are two people who are going from point A to point B, for example. So the point of Zeno was to show that the point of infinity is concept of infinity is problematic. That we cannot show that if two people have moved from point A to point B, or for example, in his what I should say, restatement, that if Achilles and tortoise, or fly and arrow, these are so if we cannot if how can we show if space is made up of infinite points, and time is also made up of infinite points, or so how can movement be possible? So how can, so because to move from one point to another point, you have to first go to the half, then you have to go to half, then so on and ad infinitum. So this is known. So in that sense, we cannot see how we can lead to some quandaries or paradoxes. So what I'll just read these things in some historical context, and maybe add. In the meantime, we can also see how the whole how this has evolved historically, and in the meantime how people have engaged with this question. Uh, because fundamentally also this Zeno's paradox is also, in some sense, I can say, it also not only talks about whether motion is possible or not, or how we can place Aristotelian notions of space and time, or how we can see the whole history of Newtonian notions of space time, or modern day notions of space and time. But it is also indirectly or inferred that it also leads us to encounter this fundamental question of infinite. What do we mean by infinite in that fundamental sense? And since if infinite is there, we as finite human beings who have finite lifetimes, so how can we address that infinite? And maybe in theological terms also, or in ontic terms, or ontologically also, if whether universe is finite or infinite. So it will also relate, this question will also relate over how we try to previously see the Kalam cosmological arguments, whether universe was infinite or whether it's finite in that sense. How Kalam cosmological arguments, you could see it, you cannot have an eternal regress. Universe should have started from at some finite point in time, and that's it. Or the creation of time was at some finite point, not back, long back. So it also is related to the notion. So Zeno's thing, these so it not only talks about whether motion and the very construction of space at some fundamental level, or the continuity of the space, but it also talks about how we deal with the question of infinite. And infinite, not only there can be very infinite is psychologically also, metaphysically also, philosophically also, maybe also mathematically, what we mean by infinite. And all these infinities or infinities, whether they are in that whole in unsurmountable infinite, how we can see it in that sense. So, question of infinite, not the Aristotelian. For example, in Aristotelian scheme of things, the actual and the potential, there is this God as a being is infinite in the sense that actual and potential are dissolved fundamentally. So that's the real infinite. But otherwise, the infinite as such in the Aristotelian scheme is not possible in that sense, or even in the way the calculus has developed. Newton, Leibniz, and Gauss and other mathematicians, they do not see infinite in that fundamental infinite sense, or what Berkeley says, infinity as ghosts in that sense. But it doesn't. But somehow it doesn't smack off that notion. So whether if there is infinite in that fundamental sense, how as we human finite beings, why should we at least try to imagine that infinite in that sense? And if Cantor says God is the absolute infinite, so what is the that absolute infinite? How is it related with the universe? So if the universe is itself finite or it's infinite, if the universe is the mirror of God, then it can also have that infinite properties. Or if it's not like that, if universe has been created, yeah, so these are various. So is it that infinite? So these are various dabbling with various metaphysical, you can say, speculative arguments in that sense. So we are going to see all of this and see Zenos, how Zeno tried to see things and how it evolved historically. And later we are going to connect it with the Iqbalian theme, that sense. So, for example, Zeno was the first person to show that the concept of infinity is problematic. Newton and Leibniz did not have a good definition of infinity, and it took almost 200 years for Aristotleian treatment of paradox, to which involved accusing Zeno of using, for example, concept of actual or complete infinity instead of potential infinity. So, in the historical scheme of things, the argument of Aristotle against or the of Zeno was that he used actual infinity, which is not, which you cannot imagine, rather than potential infinity, and accusing of Zeno of potentially failing to acknowledge line can be composed of indivisible points. So if the line is not there, so if it's made up of divisible points, so then the problem is there. If it's made of indivisible points, you cannot. The problem doesn't arise in there. So because our experience is finite in terms of actual infinite or completed infinity could not have an empirical meaning, but potential infinity could. So Berkeley, for example, had properly contextualized infinitesimals as being ghosts of departed quantities that are used consistently in calculus. If you can read the history of calculus, you can see Berkeley critiquing the foundations of calculus in that sense. So, in that context, mathematicians like Peano, Hilbert, maybe Russell, and Frege, they try to axiomatized real analysis. Students of mathematics may know it. So, but in modern day parlance, we talk of maybe Zermelo-Franklin's set theory with the axiom of choice, which blocks almost all paradoxes. And Cantor's theory of infinite sets provides the foundation of real analysis and other branches of mathematics. And these in turn maybe resolve Zeno's paradox. Whether is movement possible or not, because if space is made of divisible points, so you can always have a series which will not come to the point where so there is always that lag between two people who are trying to catch each other, or whether it's fly and arrow, or whether it's tortoise and rabbit, or whatever. So it's possible for the runner to come closer in contact with potentially infinite number of things in finite time, provided time interval things become shorter and shorter. Given 1500 years of opposition to actual infinities, burden of proof was for anyone, for example, advocating, for example, Bolzano and Cantor accepted the burden of this proof in 19th century. For example, the key idea was to see potentially infinite set as a variable quantity that is being dependent on being abstracted from pre-existing actually infinite set. So you can see you can have a potentially infinite sense. So how Aristotle tried to do away with Zeno's paradoxes, you cannot think of that absolute infinite. You can think only of potential infinite. But what Cantor tried to do is to see a potentially infinite set, which is a variable quantity, but it is somehow being abstracted from pre-existing infinite set. And each potentially infinite presupposes an actual infinite, which was in Cantor historically in 1887. So an actual infinite set is called the transfinite sense in that sense, as being a sequence of a definite subsets of that transfinite set. So Aristotle said that a line cannot be composed of points, the line being continuous and the point indivisible. Nothing continuous can be composed of things having no parts. So this is in this background. Now the inference you can have is, for example, because in Iqbal's theory of space and time, he also has tried to see the empirical notions of space and time. Whether physically space and time one is the mathematical way of continuum. So if you want to empirically also see space and time, can it be composed of space? How we can see empirically space and time? For example, inference, you can have scientific theories should be literal descriptions of reality, as opposed to today's more popular view that theories are idealizations of or approximations of those realizations. But in this case, maybe there is a logician Pfefferman. He says that mathematical ideas seldom maybe appeal to the physical realizations of the things. So mathematical idealizations and physical realizations need not necessarily match. So assuming that Achilles does complete the task of reaching tortoise, does he thereby complete a super task? A transfinite number of tasks in a finite time. So again, here the notion comes. So can we, if we want to bridge the gap of trying to reach Achilles reaching the tortoise, so you have to have infinite. So in that super task, can we complete what I should say a super task in which we have transfinite number of tasks in a finite time? Yes, so infinite number of operations in the finite time. So Bertrand Russell argues that it's possible to perform a task in, for example, in 1/2 minute, then perform the task in the next quarter, and so on until we reach that full minute and the part of it. So this is which Iqbal also talks how Russell tries to see it. So the number of tasks that can be completed in finite time, sparking the discussion whether there could be a machine that can perform infinite number of tasks in the finite time. In that sense, so algorithmically, is it possible for a machine to perform infinite number of tasks in finite time? Which is normally also called a lamp machine or Lamp's argument. So here also you have to, what's the proper definition of task, or is a lamp machine metaphysically possible? So you can have this lamp argument, so it will lead to another discussions. Or if you go to Brouwer, he says these mathematical concepts are temporal intuitions which exist a priori in that sense. So a bit of history in that sense. So apart from this thing, maybe before, it's an interesting thing to, before Zeno, people tried to discuss things more in terms of poetry. So it was Zeno. He was the first philosopher to pose arguments in prose in that sense. So the pun and the open-ended meanings, which can be which is the mark of a poetic or literary way of looking at things, as compared to the people prose thing, have to be very precise. So maybe it's also the thing that how he Zeno tried to precisely come to the precision of arguments, the way to state a given problem. So Aristotle was influenced by Zeno to use distinction between actual and potential infinity. Zeno's paradox caused mistrust in infinities. So the correct solution to Zero's paradox is in future, one of the way can be, for example, if we'll just connect it with the modern day physical theories, whether the ultimate theories of nature, whether we are quantum gravities, whether quantum mechanics and general relativity, maybe a lot of thing can be seen that we are not able to unify them because we are not accepting the fact that we assume that space-time is composed at the basic level. It may be composed of points instead of strings, loops, or any other thing. So even in trying to see the fundamental substrate of what universe can be constructed from, you have to see it in the whether a space is infinitely indivisible or there is some discrete substrata. So in that same context, we are going to revisit this Kalam cosmological argument in the way Zenos, in the light of Zeno's paradoxes. So we are going to see, for example, maybe there's also an argument of a Kantian argument, and there is also a Russellian argument critiquing Kantian argument. Maybe we'll not go with the Russellian argument, but we'll just first see the Kantian argument. For example, Kant's distinction is to infer temporal order, one must know the order. And causal order is subject to as time, not a property of things in themselves. Physics can only tell us how the world appears to us, not how it is. Means things as they are, not they are in themselves. There has passed away in the world an infinite series of successive stages of things. So there are antinomies which are associated with Kant's antinomies famously. If we assume that the world had no beginning in time, then every moment in eternity has elapsed. And there have passed away in the world infinite series of successive state of things. So you cannot make sense for the thing if universe had no beginning. So there was infinite time before and it will be after that also. We cannot have so infinite series consists of a fact. It can never be completed through successive synthesis. We cannot complete a given series. So Kant is not arguing for the beginning of time itself, but maybe beginning of time in universe, regarding past as potentially infinite and future as actually infinite. It's absurd universe had no beginning, and the series of events is already actually infinite. So in physics, if we encounter infinities, when we wonder if there might be infinity, maybe stars or for example, if the number of stars in the universe is infinite, or the matter can be thought of as being indivisible, infinitely indivisible. So maybe the way we have said that infinities can be mathematical infinities, physical infinities, psychological infinities, also in metaphysical infinities in that sense. There's a one 20th century argument of one philosopher, physicist or mathematician, Brigman. So he has declared, so just how he sees fundamentally, he tries to just do away with this Zeno's paradox in one sentence. What says? Brigman declared, with regard to the paradoxes, if I literally thought of line consisting of assemblages of points of zero length and of interval of time as sum of moments without duration, paradox would then, how would the paradox then present itself? So if line can be thought of, points can be little thought of line consists of assemblage of points of zero length. Interval as the sum of moments without duration, paradox would then present itself. So if you assume these two things, then only paradox is there. So the point he wants to mention is that you cannot imagine something which is of having a zero length. So it's also absurd to imagine things in that way. It's also not possible to imagine things it. So the if you can also relate it with more in the theological terms, how is it possibly related with the infinite God, the way I said it? So if we want to relate not false infinite, but in terms of Cantorian notion of the actual infinite, so how we can relate it with the notions of theology or God, for example? So, for example, if you have Gregory of Nyassa, so you can have existential religions, for example, self transcendence. Uh, or you can have symbolical or allegorical reasons, or you can have the way I talked of Cantor intellectually. So the distinction between essence and existence is operative. In God, existence and essence coincide, therefore infinity can be attributed to God. There is an inherent limitation to understanding infinity with category of quantification. It's a limitation because the category cannot be applied ontologically to infinity. So what Aristotle said, infinite cannot exist as actual infinity. He said that infinite is only potential infinity because it's the possibility of endless approximation. So, in that sense, the ability of human mind to think of actual infinite, which he concluded God is not that God is not infinite in that sense, uh, potentially infinite in that sense. However, he held that human mind potentially can think in as in infinite process, and that time and motion are infinite while space is finite. So the question is further you. So what is infinity in some fundamental sense? So whether it's accessible or not, or whether it's uncountable or whether it's unmeasurable. So should we consider infinity as a perfect entity, or can mathematics, which is the science of measuring, deal with infinity in some fundamental sense? So if you go to again back to Greeks, the school of Elita, school of Plato, school of Parmenides, to Greek mathematics, they took infinity as a negative concept. Why? Because it could not be reached or described in finite terms. It could not be reached or described, or it was irrational. It was formless. It could not be increased or decreased, or simply put, it was inaccessible. So in arithmetic and geometry, it meant including unending. It meant unending mathematical constructions were not allowed. So maybe Zeno's paradox should not be taken as a joke in that sense. So it led to very meaningful questions among whether we can accept the question of infinite divisibility, and in the context of whether we are talking of a continuum or not. So how we formulate in the 20th continuum hypothesis in real analysis. So in Zeno's case, we deal with space and time, which we can leave for physicists, because how exactly we can see space and time in some empirical or the physicalization of that space, mathematical space in that sense, how can physics do it. So, though quantum mechanics has some unbearable lower bound, which we normally call of Planck length, or some underlying deeper structure to the universe that also always maybe resists that subdivision. So maybe in that, if you see the quantum mechanical understanding, so it will resist maybe any that space is infinitely divisible in that sense. But if we want to connect with the metaphysical and the theological infinities, a la Cantor, for example, it was the Cantors, uh, not only Cantor in the larger debate of philosophy or theology, and Cantor maybe being one of the mathematicians, you can see. So it was Cantor's great achievement to demonstrate that we can, in fact, discuss the infinite in scientific as well as theological terms. So we are more like to say which God is an absolute infinite. It's a Cantor's phrase. But here there's a very interesting critique of Cantor, Russell. What Russell says, it's not critique also, it's also some acceptance of our way of grappling with something which cannot be grappled, which has intrinsic difficulties of trying to straitjacket or place it somewhere. For example, Russell says the absolute is disclosed through the relativity, the absolute infinity, though transfinite, and yet precisely through the same disclosure, that absolute infinity remains hidden, ineffable, incomprehensible. It is as though transfinite forms an endless wheel surrounding absolute infinity. So if we have talked of one is the transset, the eternally evolving infinite, and in the background of that infinite, in that sense. So it is as though transfinite in forms an endless wheel surrounding the absolute infinite. When we break it, that when we have the transfinite set, the wheel is all we can ever know, yet genuine knowledge about absolute infinity is forever revealed in the wheel that hides it. So this is the paradox. So you want to explain something, you are hiding it, putting it in some bracket, but it leads to a sort of uncomfortable mystery. But the very while you are placing it somewhere, it also maybe explains things. To second this sort of thing, so if absolute this infinity, or if this transfinite, which is a sort of absolute which cannot be attained and achieved, but how do other mathematicians characterize? For example, Godel wants to say the ultimate goal of such a thought of all philosophy is the perception of absolute. So we are trying to reach to that absolute infinite, even though conceptually we cannot, or even mathematically or physically, it's some unsurmountable difficulty is there. Or if we quote Hermann Weyl, he says mathematics is the science of infinite. Or if we quote Hilbert, he says the infinite has always stirred the emotions of mankind more deeply than any other question. Maybe the infinite has stimulated and fertilized human reason more than any other idea. No other question has moved human mind as compared to the infinity. So even the idea of how we reach to the that infinity in that absolute sense, from potential to the actual infinity in that sense. So maybe a lot of best minds, maybe in 20th century, in natural science and mathematics and physical sciences, they do not accept the actual infinity. Maybe they may accept the potential infinity, a la Aristotle. So in that league, you can have Galileo, Leibniz, Spinoza, Newton, Gauss. Maybe they rejected actual infinity in that sense. But George Cantor made infinity as a subject of rational research. So in the sense, rational research, in the sense that there can be rational discernment, there can be real antinomies or logical contradictions, or there can be how can resolve those contradictions. For example, real antinomies. So insight of George Cantor is that the cardinality of the set. One is the ordinality, the other is the cardinality. How big a number is there? Number of so the cardinality of set of all sets of given sets is greater than the cardinality of the set itself. This was how. So from that you can infer that some infinities are greater than other infinities, and how he resolved this infinity of potential infinity and actual infinity, and we can take actual infinity vis-a-vis God also. So Cantor resolved by claiming that of absolute infinity cannot be an object of quantitative discursive rational operation. So this is the fundamental limitation of trying to, let's see, pin down or break an argument in a discursive way, mathematical argument. So you cannot have You cannot just break. There's an inherent limitation to just see absolute infinity in that sense. So even though maybe theologically, if we can, in the Cantors argument or in the way theologians see God or Creator Allah, in that absolute, He is Basit, Muhit, in the Quranic way, the Sifat of Allah. Though He is Hayy Qayyum, He is all encompassing. So nothing in the universe is outside Him. He is beyond and beyond, be all and end all. So in that context, maybe the mathematical notions of infinity, the philosophers' infinity, they had a negative, a sort of negativity is attached to it in that sense, because you cannot fathom it, you cannot catch it in that sense. For example, it cannot be reached or described in finite terms. So it was relevant, it was formless, but it could not be increased or decreased. So what is infinity? Is it inaccessible? So it's unaccessible or unmeasurable in that sense. So even it questions whether mathematics as science can deal with this absolute infinity. But Zeno bases his proofs on the impossibility of movement, as Ashley will never reach the tortoise. So maybe the way I said, Zeno's paradox has to be taken seriously, because it may lead to meaningful questions, and we have to accept infinite divisibility and concept of continuum or not. So it the way I previously talked of whether those finite operations are possible, uh, algorithmically, going from one point, the infinite operations in time are possible. So in that sense, so these Zeno's thing fundamentally ask fundamental questions: is mathematics a science, and hence needs a validation through experiments? Whether those experiments, whether in modern day, today's computer science, we can have those algorithmic operations possible or not. Church hypothesis, Turing hypothesis, we can see it that way. So is verification of truth or falsifiability an absolute, or it depends upon the language or social factors or time, or is validation via computer science acceptable in mathematics in fundamentally also that sense? That algorithmic way of looking at those Church and Turing and other hypotheses, whether it's allowed or not in that sense. So in that sense, whether later we can just see in that sense whether we can, the two observers who are catching each other, if the infinite operations are possible in finite time, and which will make that unbridgeable gap between the Achilles and tortoise possible. So those operations, whether they are possible or not. So fundamental. So now again we are going to see these things. How we can see infinity or zeros? These things. Even if we try to see if we have the synonymity of notion of space vis-a-vis geometry, and the fundamental notion of geometry is that of we have sometimes a boundary. Um, so if the universe is finite, what is beyond the boundary? Or the very etymology of the word infinite is maybe unfinished. Um, as Aristotle always believed that infinity is always potential and never actual or completed. But the question is, for example, in today's inflationary cosmology, the way we see physics of our 21st century, we can ask in recent times, is universe finite or infinite? So the infinity of mathematics is not same as that of physics, but they are related. So what we refer to infinity is a metaphysical discourse, is object of human longing for what is ultimately true, beautiful, yet scientific cosmology has objective of unveiling the structure of geometry. But for example, the unveiling of the evolution and underlying physical laws of universe through its own powerful and highly selective methods. So whether we are going to see universe, whether the cosmic microwave background or whatever signals we are catching through those large telescopes, and then through those how those signals are assimilated through those computers or these things, those Bayesian data or whatever that data is. So they may be powerful, but they can be as selective as we can say. So is infinite something that belongs to the real world? Is the extension of cosmic space infinite or finite? Maybe Kindi and Kalosh, they are inflationary cosmologists. They may ask these questions, and in the way we have discovered, or these ideation of parallel universes are there, and they seem to be causally disconnected. They have given different realizations. So even though Judeo-Christian or even Islamic or certain variants of Hinduism philosophy, so there can be manifestations of God's infinity. You can say it that so you can say the image of a fascinating God who is creating these finite horizons of space, sharing the drama of human existences. You can see it that way, but the question is, in cosmology, does space extend to infinity? Or if so, how can something by definition beyond control be subject to matter of scientific inquiry? So maybe the way Cantor says that the ultimate notion of a transfinite set or absolutely infinite is beyond a discursive intellect. So you can also see it whether you can see it that way. If not, what is beyond the edge of beginning? If time had a beginning, what was before beginning? So again, God was creating hell for those people. Or if Leibniz or says that why is there something at all in that sense. But this is maybe one of the physicists Tegmark. He's just this sort of uh, uh, the way how can try to imagine infinite apart from the mathematical and the theological and the philosophical things. The actual infinite is not possible in that sense to imagine. But even physical infinite, how can in the presence of the universes, there is not one universe, there are multiple or many universes. Whether there are infinitely many universes, this is also a question. So, for example, as this Tegmark says, as multiple universe theories gain credence, the sticky issue of how to compute probabilities in physics is growing from minor nuisance to a major embarrassment. So it's also a sort of distaste or discomfort for physicists how to see it. Now we are going to connect it with some philosophical way of looking at things, the way we did in the previous thing, the philosophy of ontology. The way we said that in medieval discourses, philosophy like ilhayat. But in 20th century, we have notions of ontology, being, existence. So is being ultimate or not? So if being is one and complete in that sense, so it will, in the Heideggerian terms, so mathematical infinity is essentially an ontic category, and the metaphysical infinite is thoroughly ontological. In between metaphysical and mathematical sense of infinite, there exists not merely a distinction, but nearly an opposition. One is, again, the existence of being which is infinite, but you cannot imagine it, but it is existing. So it leads to a sort of Maybe you can have the how the ideas of eminence and transcendence. Transcendence is attached to infinite, absolute infinite. The imminence, once you can catch it, so the inherent this thing, they cannot be placed at one point. So that's why he's talking of mathematical infinite is an ontic category. It's only, as I said. But when you talk of metaphysical infinite, it's thoroughly ontological. You have to fundamentally believe in that sense, the existence which is possible. So in the pre-Socratean thought, the finite was pitted against the infinite, because infinite was unstable, it was fluid, and in that sense. Yes. So in the school of Nicaea, the logos metaphysics, which was the maybe philosophical lingua franca of maybe pagan, Jewish and Christian theologians, and how later Platonic metaphysicians were not so much ontological in its logic as henological, and so naturally whatever concept of being it comprises lends towards nebulous. So maybe these notions were not ontological, they were henological. Henological means, if well translated in Islamic thing, is sort of hoods. Something is being created continuously and at the same time. So this is the way Iqbal also tries to see. For example, he wants to say Muslim thinkers, for example, he says the unreality of movement means the unreality of space. Muslim thinkers of Ash'ari did not believe in the infinite divisibility of time. With them, space, time, and motion are made up of points and instances which cannot be further subdivided. Thus, they know the possibility of movement, or the assumption that infinitesimals do exist, for if there is a limit to the divisibility of space and time, movement from one point in space to the another point is possible in a finite time. Ibn Hazm, however, rejected Aristotelian notion of infinitesimal, and modern mathematics has confirmed. So Ashrite arguments therefore cannot. So Iqbal is also trying to, but maybe he is, I will not say wrongly, but he has somehow try to say how the notions of medieval Muslim theologians try to address this notion of divisibility of space and time fundamentally, and doing away with it. That God as a creator continuously creates. So the time is not as a continuous. There are nows, continuous nows existing, continuous spaces existing. So you can connect it with this henonological notion, God as a Quds. If Allah as a creator has that property, he has the capacity to simultaneously create and destroy at every moment, and that moment is also being created. Time as a property is also being created in that sense. But Iqbal is more in he's quoting Ibn Hazm. He is trying to say that he's more trying to favor the arguments of 20th century mathematics, but you can see it in that broader light. So being in itself is not really distinct from entities except temporal duration, or infinite spatial extension, or infinite divisibility. So in that sense, we can say so now we are coming to, so maybe Iqbal has tried to discuss, he has not discussed Bergson's idea, but he maybe discusses later how Bergson also has discussed Zeno's paradox. So in the interesting history of the way, so because in the later lecture, the coming lectures, we are going to connect this all, the Einsteinian notion of space-time, the Bergsonian, so you can say the Iqbalian, how he tries to appreciate things. So in the Bergsonian sense, the paradox of Zeno is due to wrong appreciation of space and time, which are regarded Bergson only as an intellectual views of movement in that sense. But he has not discussed Bergsonian time much, but Iqbal is trying to just give how Russell has tried to just discuss this Zeno's paradox, where there is infinite divisibility of space, and there is infinite time. Time is also can infinitely divisible. What makes motion possible is if there is a one-to-one map between a point in space and point in time, and which makes the movement possible in that sense. But there is a sort of discomfort which Iqbal is also trying to this interesting point, which Iqbal is trying to just maybe allude to, which I'll just read as a paragraph in that sense. What he says that, but the identity of continuity and the infinite divisibility of space is no solution to the difficulty. Assuming that there is a one-to-one correspondence between the infinite multiplicity of instants in the finite interval of time and infinite multiplicity of points in the finite portion of space, the difficulty arising from the divisibility remains the same. So the mathematical conception of continuity as an infinite series applies not to movement regarded as an act, but rather to the picture of a movement as viewed from the outside. So it's possible only if you are trying to see movement as in not being part of that movement. You can only just resolve this paradox if you are part of you are viewing things from the outside. But if you are part of that thing, so it's again sort of, it leads to a sort of discomfort, or it seems that that is not resolved in that sense. For example, he says the mathematical conception of continuity as infinite series applies not to movement regarding as an act, but rather to the picture of movement as viewed from the outside. This is what I was saying. The act of movement, that is as lived and not as thought, does not admit of any divisibility. The flight of arrow observed as a passage in space is divisible, but its flight regarded as an act apart from the realization in space is one and incapable of partition into multiplicity in that sense. In partition lies its destruction in that sense. So Iqbal is just articulating a sort of discomfort, but maybe without giving a solution also. What's the other way of just trying to do away with the paradox? The only thing maybe Iqbal is trying to say is maybe how he has tried to see how medieval Muslim theologians, the Ashrite thinkers particularly, how they try to visualize, or they try to do away, or this infinite divisibility of space and time, and indirectly that could do away with the Zeno's paradox in that sense. But the Ashrite notions of space and time can be related to the modern day notion, whether space and time are discrete or not in that fundamental sense. In that sense, those notions may be more closer to the way maybe a lot of physical theories are there. If the fundamental substratum of universe is discrete, or it's made up of some fundamental or whether time can be quantized, or whether space can be quantized, or whether matter is quantized in that sense. So if you want to see creator also in that sense, who is creating these possibilities, who is creating these things, so you can also in an henothetic argumentation you can see it. So you can say how Iqbal tries to see is more trying to stating a lot of the Zeno's paradoxes, both historically and how we are now going to see the notions of space and time, the Einsteinian notions of space and time, which we are going to follow in the coming coming lecture. That will be our maybe thing. Maybe hope this kindles your curiosity to maybe an old or maybe a debate back in history. But the point was to how to make it relevant in the modern discourses of philosophy, mathematics, theology, and physics, as well as trying to see how Iqbal tried to see things in his own era times, and how we can make it relevant to the way we see our understanding of sciences together. Maybe I hope you like this lecture, whatever this was. Thanks for listening.